Hi guys, welcome back again. In this lecture series we'll see the third theorem, which is as follows. Let f is mapping from set A to B and g is mapping from set B to C be two functions, then prove that if gof is onto and g is 1 1, then f is onto. Okay, so let us first understand that what is the meaning of 1 1 and onto function. Okay, so it is clear that gof is a mapping from set A to C. Then the meaning of onto is for each elements which belongs to set C will have pre-image in set A. Okay, that is for all z belongs to C there exists x belong to A such that gof of x is equal to C. Okay, now let us understand what is 1 1 function. It is clear that G is mapping from set B to C. Then if G is 1 1, this implies for each elements of set B has exactly one image in set C. That is, for y1 y2 belongs to set B, if g of y1 is equal to g of y2, then y1 will be equal to y2. We have to prove f is onto also. That is, f of x is equal to y. This quantity we have to prove. Okay, so let us assume that x, y and z be elements of set A, B and C. Since gof is onto function, this implies for every element z belongs to C there exists x belongs to A such that gof of x is equal to z. Right, this is g of f of x is equal to z, and we can write z is equal to g of y, since it is equal to z, right, and this implies f of x is equal to y. Since g is 1 1 function, then g of y1 is equal to g of y2 implies y1 is equal to y2. That is, y1 and y2 input here. Okay, the input of the function g. Okay, so this will be equal to each other. Okay, this implies for every element y belongs to B there exists x belong to A such that f of x equals y, and this implies f is onto function. So by end of this we have finished the third part of the lecture, and if you have enjoyed the lecture series, please subscribe to our channel and share to your friends, and your comment is valuable to us. Please comment also, and most important thing, like to motivate myself. Okay, thanks for watching. Till then, goodbye.